Alright, so this video we're going to look at a skill called Gaussian reduction or Gaussian elimination. Sometimes it's also called Gauss-Jordan elimination or Gauss-Jordan reduction, where it goes a little bit further. And it's used to solve linear systems of equations, like the three equations we have here. Now, this of itself isn't particularly difficult. You could just do this as substitution, where rearrange this to get, say, x on its own, and then put this formula for x equals 1 plus 2z, take 3y into here, and then we'd have two equations with just y and z, and then again substitute again or do elimination methods and solve it. But what if we had 40, where you might have 40 equations with a number of variables, or worse, you're not even sure that there is a solution, or there might be more than one solution. So this method does have further implications, so it is quite useful for solving these sort of things. It's not just for these more simple minimal equation type problems. The reason why you tend to see problems like this is because doing 3 by Gaussian elimination, doing 4 is really not too hard. They are long questions at times, so you want to get a bit of practice with them, but they're not super complicated. Doing a 30 by hand would just take probably a whole day to do, so we let computers do it for us, but by hand 3 is pretty straightforward. So let's wade into it. So we have here a set of unknowns, our x's, y's and z's, and we have in front of them coefficients, and we're told that various coefficients of these variables end up equaling some constant on the end. So what we're going to do is write this as a matrix, and we're going to put this in augmented matrix form. So let's start off by making our matrix of coefficients. So we're going to have 2, 2 and 1, so I'm just getting the ones in front of the x's. In front of the y I've got 1, 2 and 3, and then finally in front of the z's I have -1, -1 and -2. Do be aware of negatives, and we're going to augment this, so we're going to put a line there just to show the augmentation, and we have our constants of 1, -3 and 1, and let's put our brackets to show that this is indeed a matrix. So the Gauss-Jordan method or Gaussian elimination method wants us to get to what we call row echelon form, where this lower triangle here underneath the main diagonal goes to 0, and if you keep going it further, which I believe is the Jordan method, you end up with this top triangle going to 0 as well. These numbers down the middle here, we call these the main diagonal, and we want those to be 1. How you get them there doesn't matter. You can swap rows around. You can multiply rows by numbers. You can divide rows by numbers, but you can't add or subtract. You can add or subtract multiples of other rows. So I can't just go, oh, let's just take away 1 from all these, but I could say, oh, let's take away 1 lot of all of row 2 away from these. So this is how we're going to get our numbers down to being zeros. We can also swap things around. Alright, so let's just wade into it. The first thing I'm going to do, well, row 3 here has a 1 in the leading position, so I'm going to swap that up. It saves me having to do any extra math. So now we would have 1, 3, -2, augmented with 1. Then on our next line we're going to have 2, 1, -1, augmented with 1, and 2, 2, -1, augmented with -3. Okay, so all I've done is I've just done R1 swap with R3. In this case the R stands for rows, and it's good to show this sort of working as you're going through. It helps you go back to it and go, oh, this is what I did, and it helps with communication towards your teachers. So let's have a look. The next thing we want to do is we want to start turning this column. We're going to work down the columns first into zeros. This is already a 1 for us, which is a happy coincidence, but that won't be 1 for very much longer. So what we're going to do is we're going to use this number and take away some multiple of this 1 above it. because if we think about it, if I want to turn a 2 to a 0, I just need to take away 2 groups of 1, don't I? So if this main diagonal is already a 1, then you're already off to a good start. There's also another way of doing this called pivot form, which combines these two operations in one go. So when we get to converting this shortly, it could save us, maybe 30 seconds or so of working time. But if you're comfortable with this process, you can work through it. So R2 will become, okay, some people like to write it where they'll do the operation arrow leading to the row. I prefer the other way because that's how we think. Okay, I've got R2, and instead of R2, I'm going to do this thing off to the side. So what I'm writing here is essentially some operation I'm about to do is going to go into R2 instead. And what I'm going to do is I'm going to take R2 and I'm going to subtract R2 amounts of R1. Okay? So let's have a look at this just using this first number. So instead of that 2, I'm going to go, well, I said R2, 2, take away 2 times 1. Well, that equals 0, doesn't it? Okay, so we'll have across the top 1, 3, minus 2, augmented 1, okay, and we've just said that will be 0. The next thing we're going to do, okay, so now we're going to do it to this line. So we're going to have 1 take away 2 times. Okay. The thing is, we have to use this same number out the front because we did 2 lots of this. We've got to do 2 lots of this. We can't do just 1 lot of this. So maybe I shouldn't have actually said R2 there. Apologies. In this case, we'll call this a special one. My teacher called it the pivot because this is the number we are sort of pivoting around. So let's just say 2 lots of R1. So 2 times, well, what's in R1? 3. 1 take away 6 will give us -5. So I'm going to have a -5 here. Okay. Do it for our next row. -1 take away 2 lots of -2. Okay. Equals, let's see, well, -2 times -2. Let's put a bracket in there to show that it's multiplication. -2 times -2 is +4. -1 plus 4 gives us 3. But we've also got to do it to this augmented line as well, so can't forget that. So that's going to be, well, 1 take away 2 lots of, well, 1. And we get, well, 1 take away 2 gives us -1. Okay. Now we have to do something to, I recommend sort of either doing it row by row, or you can do a couple of rows at once. It does depend on how comfortable you feel with it. So I'm going to do, just copy down the third row here, 2, 2, -1, -3. And our first step is done. Okay, we could have done a second operation as well, but let's keep it simple. So now I want to turn this one. I want to pivot this number here, that 2 there, and turn that into a 0. So let's do the same thing. R3 in this code is coming from R3 take away, what's the pivot? 2. 2 lots of R1. We could have you can use the row, this other row, but if I did 2 take away 2 lots of 0, well, 2 lots of 0 is 0, so it's not going to do anything, is it? That's why that 1 up there is so useful and important. And when we get to doing these other ones shortly, you'll see why as well. So why this sort of format works well. So let's work through these numbers. So let's start our next matrix. So we've got 1, 3, -2, augmented with 1. And we've got 0, -5, 3, augmented with -1. Now let's work on our new third row. So R3, we're going to take R3, that was 2, take away 2 lots of R1, which was 1, so that equals 0, because hey, that's what we want. We want that 0 in there. Let's do our next one. So our number is 2. Apologies. 2 take away, and now we want 2 lots of R1, which is 3, So we've got a similar thing before. Negative 2 times 3 is 6. So 2 take away 6. In this case will give us, well, negative 4. Okay. Let's do our next one. Minus 1. Take away 2 times minus 2. So that's going to give us positive 3. And then, yep, our last one was minus 3. Take away 2 lots of, well, what's at the top here? It's a 1. Negative 3 take away 2 is negative 5. So we've now completed our first row. Okay. Now our next thing to do is we need to turn this number here into a 1. And the easiest way to do that, just divide by itself. We don't need to do anything fancy. Okay. So I'm just going to go, alright, well, R2 becomes R3. So we can't subtract another row from it. We could subtract multiples of R1 from it, but all I can do, really need to worry about, is just dividing by a certain number. So in this case, I'm just going to divide by minus 5. It's okay to multiply a line or divide a line because we're doing the same thing to every number in it. It's like rearranging equations. Because I'm dividing everything by the same number, it's still going to work. And then in which case now we will end up with 1, 3, minus 2, augment 1, 0, minus 5 divided by minus 5 is just 1. So I don't think we're fine with that. 3 divided by minus 5 is just negative 3/5. I like to leave them as fractions because decimals get a little bit longer, and if you've got non-defined, like repeating decimals, you start losing precision. Try to keep them as fractions. And then we've got minus 1 divided by minus 5, so it's going to be 1/5 over there. And our lower line is still the same. Okay, and minus 5. Okay, so we've got all zeros, we've got a 1, now we need to work on this number here to turn it to a 0, and then we'll work on that number in a moment to turn it into a 1 as well. So let's work through that. So R3 becomes, we're going to use R2. We're not going to use R1 because if I use R1, I need to use multiples of this 3 up here. And it's much easier to use multiples of this 1 instead. So I'm going to do R3, take away, minus 4. Okay, we still have to do the takeaway, lots of R1. Sorry, not R1. I'm having a dumb moment. R2. Now, the reason I do it like this is because let's use this here. Because if I'd used R1, that number would still have to take away some 4 groups of this, when we would have ended up with a negative 4 there, or positive 4. So, yeah, positive 4. So let's do it from R2, because 0 and 0 are going to be 0. That's the trick. So let's write that out. So R3, 0, take away, negative 4 lots of 0 equals 0. Great, no change. Next one. Negative 4 take away negative 4 lots of 1. So negative 4 times 1 gives us negative 4. Negative of negative is a positive. Negative 4 plus 4 gives us 0. So let's start writing. I'll just work all the math out here. Apologies. 3 take away negative 4 lots of, or what's the number above it? Negative 3 over 5. Okay. Equals, okay, so let's work through that. Negative 4 times negative 3 gives us 12, 12/5. 3 is the same thing as 15/5. So I have 15/5 take away, because I've got a negative of a negative of a negative, so it's going to be subtraction. So 15/5 take away 12/5 gives us 3/5 as well. Okay, it's just kind of a weird coincidence there. That wasn't intended by any case. And that number, was that a 5? Yes, that was a 5. Sorry, my 5s sometimes look like S's. Let's do this last one. Minus 5 take away negative 4 times 1 over 5. So let's see, we've got negative negatives, that's a positive. That's going to be 4/5. So negative 5 plus 4/5 ends up being 4 and 1/5, or would be equal to 21/5. I believe the cat just did something stupid. So let's fix up our new matrix. So we've got to have 1, 3, minus 2, augment 1, 0, 1. We haven't touched this number yet, so that's still minus 3/5, and that's still 1/5. 0. Second number was 0. Next number was 3/5. Next number was 21/5. Alright. Next worry. So that's a 0, that's a 0, that's a 0. So we've made our lower triangle 0. We need to now turn our main diagonal, so this number here, that's 3/5, into a 1. So 3/5 divided by 3/5 gives us 1. So let's do R3 equals R3 divided by 3/5. So we're going to have 1, 3, minus 2, augment 1, 0, 1, minus 3 over 5, 1 over 5, 0, 0. Well, 3 over 5 divided by 3 over 5 equals 1. That's why we did it that way. 21 over 5 divided by 3 over 5. Well, let's rearrange that. So that's going to give us 21 times 5 over 5 times 3. The 5's will cancel. 21 divided by 3 equals 7. Now, if you got it in this form, you can solve it at this point. It's perfectly solvable here by using backward substitution. So remember, this will be your x coefficient here. So this would be x, this would be y, and this would be z. Okay, and so we can see, oh yeah, z has to equal 7 in this case. Okay, and then we would substitute. Well, we have negative 3/5 of z, and we know that z equals 7, so we'd substitute that in there, and then work out and find out what y was equal to, and then we can do the same thing and work out what x is equal to. The Gauss-Jordan method uses, I believe, similar things to this. I'm really not familiar with the terminology. I just remember this one because once you do this, the rest of it's trivial. So who cares about doing this top diagonal thing? But you're just going to do the exact same thing we did here. Okay. So I have this main diagonal of 1s. So this row would now take away, well, actually I'd probably start with this row first to get rid of these two numbers. But say here, I would take away some amount of 1 to turn that to a 0, and then that would turn into something involving the 7s. And then I would do this row, something, this one taking away some 1s to turn that to a 0, and then whatever that turns into, doing that, taking away some 1s, because this would then be 0 take 0, and you'd end up with a 0 there. And then you'd have 1, 1, 1, and you'd have your x, y, and z values. I personally think that's kind of tedious. At this point, I'd be doing something like this. So therefore, z equals 7. Okay. Y minus 3/5 z equals 1/5, and x plus 3y minus 2z equals 1. And we can rearrange this. So I substitute 7 into that. I'm going to get y minus 21 over 5 equals 1 over 5. Let's add these two together. So I'm going to add that across. We're going to have y equals 22 over 5, which would equal 4.2. And then substituting both of those into our original thing, we get that x plus 3 times 4.2 minus 2 times 7 equals 1. X plus 3 times 4.2 is 12.6 minus 14 equals 1. So x would equal, let's see, 15, take away 12.6, 2.4. Okay, now I am a little bit concerned though about these numbers here and here. The fact that this came out as being a whole integer for an introductory linear algebra set, but these other two are coming out as very annoying decimals might indicate that I've done some multiplicational division wrong here somewhere. So if I have, do point that out to me. However, the method is the same. Okay, the goal is that we put a 1 up the top, we make these into zeros. We get a 1 into our next main diagonal, we make zeros underneath it. We get a 1 to our third diagonal, and we make zeros underneath it. So the thing is, this, we didn't really need to make this. I could have just said here 3/5 of z equals 21.75. Okay, and then we could have rearranged from that, and that 3/5 of z equals 21.5. That means 3z equals 21. So 21, so z has to equal 21 over 3, which is what we found out over here anyway, which therefore equals 7. So you don't necessarily need to convert these to ones, but it does make it a little bit easier to do some of the math. Alright, so that's that first one, and I have a second one here. So here it's written in a little bit different form. 2x1 plus x2 minus x3 plus x4 equals 4, and then 2x1 plus 2x2 minus x3 minus 3 groups of x4 equals 1, x1 plus 3 x2 minus 2x3 plus x4. Why do I keep writing xy? x4 equals 0, and then minus x1 plus x2 plus x3 plus x4 equals minus 1. Now, the fact that this now are using x as a subscript is no different. We could have used x, y, z, and w. We could have used a, b, c, d. We could have used alpha, omega, beta, and gamma. It doesn't matter. The symbol, so it's just a symbol. It represents something that we don't know. But it's the same process. So let's write our augmented matrix. So down our x1 column, 2, 2, 1, minus 1. Down our x2 column, 1, 2, 3, 1. Down our next column, minus 1, minus 1, minus 2, and 1. Down our final column, 1, minus 3, 1, and 1, augmented with 4, 1, 0, minus 1. And I'm going to do the exact same thing as before. First thing I'm going to do, I'm going to rotate R3 up into R1 so that I've got a 1 leading at the very start. So my new one, R3 swapped with R1 gives me 1, 3, minus 2, 1, augment 0, 2, 2, minus 1, minus 3, 1, 2, 1, minus 1, 1, 4, minus 1, 1, 1, 1, minus 1. Okay, the thing is, these orders don't matter. You can swap them around however you feel that you need to. Okay, so in this case, I can see that if I want to turn that to a 0, the same rule will turn that to a 0 as well, because they're both 2's. So I'm going to write a couple of rules out I'm going to do here. So R2 is going to become R2, take away 2 lots of R1, and R3 is going to become R3, take away 2 lots of R1 as well, because in both of these it's going to be 2 take 1. I can also put my 4th row, R4 will become R4, take away -1 lots of R1. Okay, so, or if we wanted to just simplify that, we could just do R4 plus R1. Okay, so remember the goal in each of these is to try to get this first column to 0. The rest of the numbers will just do what they do. Then we change our next pivot, work below, change our next pivot, work below, and that one we can change or not, it really doesn't matter too much. They like to see it as a 1, it's just a finicky thing, don't super stress. So let's chuck our math through this. So we're going to end up, top row is going to be 1, 3, minus 2, 1, augment 0. This is going to go to 0, right, just because it should do. And if I check that, so let's see, 2, take away 2 lots of 1. Okay, so 2, take away 2 times 1 gives us 0. Great. Alright, 2, take away 2 groups of 3, minus 4. Minus 1, take away 2 groups of negative 2. So that's going to be minus 1, take away 2 groups of negative 2, positive 4. So that's going to be 3. Negative 3, take away 2 groups of negative 1, take away 2 groups of 1 is negative 5. 1, take away a bunch of zeros is still 1. So that's nice and easy. Our next one, that should go to 0. 1, take away 2 groups of 3, negative 5. Minus 1, take away 2 groups of minus 2. Yeah, this one's really similar to that other one just now. You've got a 4th row as well. Minus 1, take away 2 groups of minus, well, see these two numbers are the same, so that number's going to end up being the same again. 1, take away 2 groups of 1 gives us minus 1. Yeah, 1 take away 2 groups. Yeah. 4 take away some groups of 0 is still 4. Okay, that's working out quite nicely for us actually down there. And we can see, well, that last one's going to be minus 1. Oh, actually, no, sorry. Yeah, it will, because we're just going to add 0 to it. And 0 plus 0 is 0. So anything plus 0 is just itself. So negative 1 plus 1 is 0. 1 plus 3 is 4. 1 plus minus 2 is minus 1. 1 plus 1 is 2. So after all those rules, that's our new matrix. Okay. Now, the next thing I want to do is I want to turn this row, this number here, this minus 4, into a 1. So I'm going to divide everything here by minus 4. Okay. So let's just go down a bit. 1, 3, minus 2, 1, augment 0, 0. So I'm going to do row 2 comes from row 2 divided by minus 4. Minus 4 divided by minus 4 is 1. 3 divided by minus 4 is minus 3 over 4. Minus 5 divided by minus 4 is 5 over 4. And 1 divided by minus 4 is minus 1 over 4. 0, minus 5, 3, minus 1, 4, 0, 4, minus 1, 2. Oh, and minus 1. Good thing is now we've done that first row. I only need 2 rules now to get these two to be zeros. So this one here we're going to have minus 5. So we're going to have R3 comes from R3, take away minus 5 being our pivot number times R2. And R4 will come from R4, take away 4 times R2. Okay. Note, I'm using R2, I'm not using R1, because R1 would end up then having these numbers taking away some 1s. Right now we've got these numbers taking away some zeros, so that they don't cancel, or that they don't change. So let's work our way through that. Let's copy in our first 2 rows. 1, 3, minus 2, 1, 0, 0, 1, minus 3 over 4, 5 over 4, minus 1 over 4, 0. Alright, so this should be 0, but let's double check. So minus 5, take away minus 5 times 1. Minus 5 times 1 is minus 5, minus over minus positive, minus 5 plus 5 gives us 0. Let's look at our next row. 3, take away, well, let's just turn that to a plus, because it'll just make it easier in our brains to deal with. 3 plus 5 groups of negative 3 over 4. Whew, okay, so let's just do a little bit of working after that. So 5 lots of that will be negative 15 over 4. We want to add it to 3, which would be the same thing as 12 over 4. So that's going to be minus 3 over 4. I can hear my cat meowing in the background there. Let's have a look at our next one. So we're going to do minus 1 plus 5 groups of 5 over 4. So that's going to be minus 1 plus 25 over 4. That's the same thing as minus 4 over 4. So that's going to be 21 over 4. And finally for here, our last number, we're going to have 4 plus 5 groups of minus 1 over 4. So that's going to be negative 5 over 4 plus 16 over 4. 16 take away 5 gives us 11 over 4. Alright, wonderful. Now for our final row, we had 0, and let's do a substitution. 4 take away 4 lots of 1 is indeed 0, as it should be. Let's go for our next one now. So negative 1 take away 4 groups of negative 3 over 4. So let's put that together. The negative 1, that's going to become a positive. We're going to end up with plus 12 over 4. That would be negative 4 over 4. So negative 4 over 4 plus 12 over 4 would give us 8 over 4, which equals 2. And for our other one, we have here 2 take away 4 lots of 5 over 4. Oh, that's good. We're going to end up cancelling that there. So that's going to be, those will cancel. We're just going to have 2 take away 5 equals negative 3. And finally, we're going to have negative 1 take away 4 lots of, what was that over 4? Negative 1 over 4. Yep. Take away negative 1 over 4. Negatives will cancel. Those will cancel, so we're just going to have negative 1 plus 1, so that would give us 0. Okay, so far we've got first one, second one, now we need to turn that to a 1, and we can see we're going to divide every row there by 3 over 4. Which, remember, is the same thing as just multiplying by the reciprocal if you want to do it that way, or you can do it as division to division. It really does depend on what you prefer to do mentally. So let's have a look at a couple. Let's look at how we turn that. So R3 is coming from R3 divided by negative 3 over 4. So anything divided by itself is 1, so the first line becomes trivial. 1, 3, minus 2, 1, augment 0, 0, 1, minus 3 over 4, 5 over 4, minus 1 over 4, and 0, 0, 1. Okay, so 21 over 4 divided by negative 3 over 4 is the same thing as multiplying by 4 over negative 3. Which would give us, well, negative 7. If we have a look at our other line, 11 over 4, 11 over 4 multiplied by 4 over negative 3 would give us negative 11 over 3. Don't need to really write that out. Let's keep going down. And we need to copy our last line, 0, 0, 2, minus 3, 0. Okay, and we are almost finished off with this here, so let's go. So R4, we've only got one row to do this time, comes from R4, take away pivot number 2 times the row above, R3. So let's substitute that in. 2 take away 2 times 1 is indeed 0, which is what we expected. 1, 3, minus 2, 1, 0, 0, 1, minus 3 over 4, 5 over 4, minus 1 over 4, 0, 0, 1, minus 7, minus 11 over 3, 0, 0, 0. And let's see, what was our rule? We're going to take, let's just move this down a bit, make it easy to read. So we wanted R4 is going to be R4 minus 3, take away 2 lots of minus 7. So 2 times minus 7 is minus 14, minus 3 is going to be minus 17. And we want for here 0, take away 2 lots of negative 11 over 3, so it's going to be negative 22 over 3. Okay, now we could divide this last line by 17 to turn this into a 1, and then we'd end up with, I mean, that really isn't that hard to do. So if we divide that by negative 17, that becomes 1. So R4 is R4 divided by negative 17. So that one, so negative 22 over 3 times negative 17 gives us, well, 3 times 17 would be 3451, and negative would cancel, so we'd end up with 22 over 51. So our x4 value equals 22 over 51, backward substitution, so we'd have 7 groups of it, work out that, rearrange, and you've just got substitution. Alternatively, we could use the same method just for our upper triangle that we've just done in order to slowly cancel these down to zeros. It's the same thing no matter which way you look at it. So we could go, alright, well R1 is going to equal 3 groups of, because we want to get rid of that 3 groups of R2. So 3 groups of 0 is 0, 1 take away 0 is 0. 3 groups of 1 is 3, 3 take away 3 groups of 1, or 3 take away 3 is 0. Minus 2 times, minus 3 over 4 is negative 9 over 4. Negative 2 take away negative 9 over 4 is some number. Same thing for that, same thing for that. And eventually you would work your way through in order to solve out that numbers, then those numbers. You could do, for example, this one here, you could take away from here. This one could also take away from here, actually, if you wanted. Oh, no, you can't do it from there. This one here, you've got to take away from here. Okay, so that you can use that 1. And then this row here would take away from this. It's just the opposite. So you'd only have to do 1 here, like we only had to do 1 there. And then you'd have 2, like we had to do 2 for over here. And then you'd have 3, like we had to do 3 for that first column. So the rule to remember, though, is that if you're doing a replacement for Rn, what you're going to do is take your Rn value, you're going to subtract it from whatever the pivot is. So we're going to call that Rnp, the pivot, or first non-zero, times R, let's go M instead. Now M could be, generally it's probably going to be the row above. If you look at everything we did up here, it was always with the row above. So maybe here instead of M, let's do N, take away 1. Because everything I've done has been the row above until you get to doing the top triangle, and then it's the opposite. So, you know, you might want to consider how you deal with that. Okay, so I hope that makes Gaussian elimination a little bit clearer. All you can do is practice. It's not a particularly deep skill, it's just a repetitious and very boring skill to do. Best of luck.